Okay, now we're going to use summation notation to write a series. So it can be tedious writing out all of the numbers in a series or in a sequence in order to evaluate the series. So you can use what's called summation notation. So summation notation has this Greek symbol that's called sigma. So this is using the Greek letter sigma, which looks like this. And then in summation notation you have what's called a lower limit. So you're using the lower limit as the least value. So I could have n equals 1, or sometimes there's I or K. These variables can change, but this variable needs to be the same as the variable over here. So you have some type of explicit formula or an expression over here. So I'm just going to do 2n. So this is the lower limit is on the bottom. So at n equal 1 we're going to plug in 1 for n, and that's going to be the first term of the sequence. So the first term of the sequence is 2. Then we're going to plug in n equals 2 and do 2 times 2. So the next sequence is going to be 4, or next term in the sequence is going to be 4. Then I'm going to do the next counter, which is going to be 3. 2 times 3 is 6. So far. And so when you stop is the upper limit, and that you could stop at maybe 25. So this means that I'm going to plug in 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, all the way to 25. This is the upper limit, this is the lower limit. So to figure out how many terms there are, what you do is you take the upper limit minus the lower limit and add 1. And we'll do that now later on the bottom. So number 1, use summation notation to write each series for the specified number of terms. So what I do is I use my sigma. I always start at 1, and it's 50 terms, so I go to 50. And my number of terms is 50 terms because 50 minus 1 is 49, plus 1 makes 50. Now to figure out what goes right here, I need to have n as the same variable. So what I'm going to do is I'm going to write, this looks like an arithmetic formula. So I'm going to write the explicit formula for arithmetic sequence. So it's going to be a sub 1, which is 8, plus the common difference, which is 8, times n minus 1. And then what I do is I simplify this. I know this is more of a simpler one, but this technique works every time when you have arithmetic and geometric sequence. So then I'm just going to write 8n right here. So I simplified this part and wrote it right here. Okay, number 2. So I use my summation sigma. There's 6 terms, so n equals 1 to 6. Now to figure out what goes right here, I'm going to look at what type of sequence this is. It's arithmetic, and I can kind of see that it's just going up 2, and it's starting with 2. So if I put 2n right here, if I plug in 1, I get 2. If I plug in 2, I get 4. If I plug in 3, I get 6. And so this is what I want. So it works. I always kind of double check to see if it works. So this sequence is going up by 5. So a common mistake people see is just writing 3 plus 5n, because the first number is 3 and it goes up by 5n. But that's not going to give you your first term, because if I plug in 1, I'm going to get 3 plus 5 times 1, which is 8, so that doesn't work. So that's why I would use my technique of doing the sigma part, starting at 1, ending at 9, and then going off to the side and writing the arithmetic sequence formula for it. So it's going to be a sub 1 plus the difference, which is 5, times n minus 1, and then simplifying this. So this is 3 plus 5n minus 5. So this is 5n minus 2. So let's check to see if it works. So if I plug in 1, 5 minus 2 is 3. If I plug in 2, 10 minus 2 is 8. If I plug in 3, 15 minus 2 is 13. It works. So a common mistake is just to do 3 plus 5n. Okay, number 4, use the series. So remember, a series is adding up the sequence. Find the number of terms in the series. So to find the number of terms, you do 18 minus 1, which is 17. So there's 7, and then you add 1, so there's 18 terms. I know that can just be tedious. Oh, can't we just look at the top number? It's not true, because sometimes you could start with n equal 2, 3, 4, anything different besides 1. So I just always subtract the upper, lower limit and then add 1. And then evaluate the series. Okay, so to evaluate the series, we're going to use the formula for the sum of a finite, so finite means it stops, arithmetic series. So the formula is the sum of an arithmetic sequence is the number of terms divided by 2 times the quantity of the sum of the first term and the last term. This is where this summation notation is really handy, because it's easy to get the first term and the last term by plugging in the lower limit and the upper limit. So the sum of the sequence is the number of terms, so in this case there's 18 terms, divided by 2. Now to get the first term, I'm going to plug in 1. So it's going to be negative 2 times 1 plus 3, so that's 1. To get the last term, I plug in the upper limit, 18, so it's negative 36 plus 3 is negative 33. So I'm going to do 9 times negative 32. And I get negative 288. So this will be much faster than listing out all of the terms and adding them. Okay, then down here, for each sum, find the number of terms, the first term, the last term, and evaluate. So the number of terms is 10 minus 1 plus 1, which is 10. The first term is plug in 1, so 1 minus 3 is negative 2. The last term is plug in 10, so 10 minus 3 is 7. And to evaluate, I'm going to use the formula for the sum of a finite arithmetic sequence. So that is the number of terms divided by 2 times the quantity, the first term plus the last term. So this is going to be 5 times 5, which is 25. Okay, number 6. So the number of terms is 10 minus 5, which is 5 plus 1 is 6. The first term is plug in 5. So it's 5 halves plus 1, so it's 3.5. The last term is plug in 10, which is 6. Because half of 10 is 5, 5 plus 1 is 6. So to evaluate, I'm going to do the number of terms divided by 2 times the first term plus the last term. So I get 28.5. And then number 7, the number of terms is 97 minus 38 plus 1. So there are 60 terms. And then the first term, I'm going to plug in 38. So 3 times 38 minus 5. 3 times 38 minus 5 is 109. And the last term, plug in your upper limit. So 97 times 3 minus 5 is 286. And then to evaluate, I'm going to do the number of terms, which is 60, divided by 2, times the first term, which is 109, plus the last term, which is 286. And I get 11,850. So evaluate means add up the series. You can use the arithmetic finite series formula.